So now we're into our final chapter of statistics and probability. In this chapter, we'll be learning about the applications of how to calculate different statistics and calculate the probability of different situations given by the question. So I'll be start by defining a few terms, but before I start explaining different things, I have to let you know that this unit is comparably easier than the other units that you will be studying in this curriculum. However, as you reach towards DP, this unit becomes very difficult as different kinds of series comes in and probability functions come in. So I recommend you guys really build up a sufficient pillar in order to study and guide your way through the whole unit throughout up till DP. So, all right, let's get started. First, let's look at the definition. So, probability is the mathematical chance of something happening. Yes, I mean, sure, we all know what probability is. So, let's look into the specific terms used in math, which are sets and set operations. So, first of all, set is a collection of objects or things. Example, numbers. So, set of all factors of 12 is 1, 2, 3, 4, 6, 12. Notice we place the factor within curly bracket with commas between them. We often use a capital letter to represent a set so that we can refer to it easily. For example, we might let f equals set 1, 2, 3, 4, 6, 12. We can say that f is a set of all factors of 12. So currently what this is trying to explain is that set is literally just sets of numbers. For instance, in math, we will call it sets of numbers. So any number series can be a set. For instance, here we go. This would also be a set, and this would also be a set of numbers. So this is not something really complicated. We just call these things sets, and each object in a set is called element or member. So these things are called element or member. All right, that's pretty straightforward. Now then, what is subsets? Let's read the prompt here. Suppose P and Q are two sets. P is a subset of Q if every element of P is also an element of Q. That is the most complicated way to express subsets, but don't worry, I'll make it more easier. Let's ignore the notation for now, and I'll start by explaining what subsets are. So we just said that set is just sets of numbers. Let's say we have a set called F, which contains the value 1, 2, 3, 4, 5, and 6. And let's call another set of C with the numbers 2, 4, 5, and C. Notice how each numbers within the set of C is also a value within the number of set F, as can be seen here. Now, because all the elements of C is a member of F, C is a subset to F. So F holds C within its own set. All right, so that is basically what subsets are saying. If, for instance, C had another value of 7, C would not be a subset of F. All right, then here are a few notations that you guys have to understand when you're solving mathematical questions about statistics and probability. First is this E looking guy, which means the element or member of the set. And E with a not, normally when you have a line, like in the original notation, it means not. So you know how this is an equal sign and this is a not equal sign. So this notation reads that it is not an element or is not a member of the set. These notations are used to express that the set is empty. So if I just said F equals just blank, then F does not have a set of numbers. And this reads that it's a subset of. So in this case, if we bring back C as a subset of F, we will call it F is a we'll call it C is a subset of F. And then next we have NS, which means the number of element in set S. All right, this can be easily explained as we look at the example here. So 4 is an F. So these statements written here are all examples and right examples in expressing the number. So for instance, 4F 4 is an element of F because we have 4 right here. So this statement is true. 7 is not here in the element section. So 7 is not a member of F. 2, 4, 6 are all values within the subset of F. So we can say 2, 4, 6 is a subset of F. And finally, N means the number of elements within set S. So 1, 2, 3, 4, 5, 6. So the answer would be 6. Not too difficult yet. However, it gets a little confusing as we are introduced to union and instruction. Let's look at what these are. If P and Q are two sets, but it gets quite difficult as we are introduced to union and intersection. So let's look at, I call it N, but it's actually called intersection. So P intersection Q is literally the intersection of P and Q and consists of all elements which are in both P and Q. So the key word here is both. Let's give it another highlight because it's important. And then PUQ is the union of P and Q, consisting of all elements which are in P or Q. All right, this is very confusing if you put it into words, but it's very easy when you look into the example. All right. All right, before we move on to the example, I'll first tell you what mutually exclusive means. Sometimes the questions are going to tell you that P and Q are mutually exclusive, or set F and C from the previous question are mutually exclusive. What mutually exclusive mean is that the two sets are disjoint if they have no elements in common. So for instance, if I have, reading the red notes here. So if I have a set of A, which consists the number of 1, 3, and 4, while B, there's a set called B, which has the number 2, 5, and 6. You can see how no numbers here overlap. Now, that's why we can call that A and B are mutually exclusive. So it means that no same values are between the sets. So in the example my friend gave here, because 2's overlap, these two sets are not mutually exclusive. All right, then what does union and intersection mean? First of all, before I introduce you to union and intersection, I first want to point out how to memorize this. Because these two symbols look very similar, it gets quite confusing as we are introduced to this in a exam situation. So I really want you guys to remember that PUQ is always union, and PNQ is intersection. You can memorize it through the alphabets they use because union obviously starts with a U, so you guys can understand that it's a union. Intersection, on the other hand, has N on the second letter, so I want you guys to remember in this fashion so that it's a little more easier to understand. Then, what are these union and intersections? Well, union is when there are overlapping numbers between two sets. This can be looked through the question here. So, for example, if there's a set named P with the value 1, 2, 4, 5, 6, 8, and a set called Q with the value 2, 5, 6, then P and Q, P intersection Q, would be the same numbers that exist within within the different sets. So currently, number 2, 5, 6 are both in the two sets. So these two are the values of P and Q, P intersection Q, as 2, 5, 6 are in both sets. However, PUQ is like a universal. PUQ are just all the elements within the two sets. So it would be all the numbers listing from here. So all the numbers from P of 1, 2, 4, 5, 6, 8, and 0, 2, 3, 5, 6, 8, 6, 7. So all the numbers combined to create a set that consists all these numbers together would be P union Q. So as you can see, number one, 2, 4, 5, 6, and 8 is in here, and 0, 2 is already in there, and 3, 5 is also already in there, 6 is already in there, and 7. A set that consists all the elements of the two sets are union of the two sets, as these are the elements within which are in P or Q. This can be a little confusing, but if you do a few practice question, about 3 or 4 in the Haese Mathematics textbook, it will very help. You will understand in a short time. The page numbers are written here. It's the grade 9 textbook of page 102. So please do like a 5-minute practice, and I believe that's all the time it's gonna take for you to understand the whole concept. Now moving on, special number sets. Remember from Unit 1. Yes, I have already introduced this topic in the Unit 1 video, so I'll skim through it real quickly, but these are just a set of numbers that mathematicians came to agree that this letter normally represents this set. Obviously, if the question tells you otherwise, it can change, but normally if there's a question saying that if there's a question noted this way, it means that x is just a number of natural is a natural number. So it's telling you the region of the answer can be. So n normally notes natural number. That's pretty easy. Z means integers. So every values that are not a decimal, imaginary number, and etc. And z plus, because we have the plus here, is positive integer. Z minus, in the other hand, is negative integer, while q is set of all rational numbers, which are real numbers and which can be written in the form of p over q, where p and q are integers. So just generally, all rational numbers are noted in q. While q naught, normally this is a coding term, but if you have a comma here, it means not. So Q naught is called all of irrational numbers that I also introduced in the Unit 1 video. So if this confuses you, this is a sign that you have to review Unit 1 again. So it's numbers like root 2 and cube root 7 and pi as these numbers belong to Q naught, showing that these are not real numbers, which are numbers that can be placed on the number line, like this way. These units are dealt more heavily in Unit 1 video, so please check that out. Complementive set. All right, so in this section, we're going to be learning about universal set and complementary sets. First of all, universal set is very important. Whenever there is a set represented by U, it means the whole set of numbers. So normally when we do these type of statistic questions, I like to express it in a box of whole number series, and this is going to be U. And when we draw Venn diagrams, these Venn diagrams are going to represent the set of numbers. I'll explain this more in depth as these are introduced later on this video. But basically, universal set is all the set of numbers. So if Z has the number 1, 2, 3, and F has the number 3, 2, 6, the universal statement would be the union where it's 1, 2, 3, and 6. So it's just all the numbers that are given within the question, the maximum set of numbers. And then complementary set is all elements of U that are not in A. So, as I introduced, this notation means not. For instance, so if the question if the question informed you that U, the universal set, has numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, and set A has elements of 1, 3, 5, 7, 9, then the complementary set of A naught would be every number in U that is not in A. So if I try just erasing as what my friend did here, 1, 3, 5, 7, 9, the numbers 2, 4, 6, 8 would be a complement of A, which is denoted as A apostrophe, A naught. So, something useful to look over. Uh, there is no intersection between A and A naught because A is a set and A naught is a set of numbers that are not A. So there would never be an intersection between this equation. So this is a way of representing NA, not available. So just understand that A intersection A naught does not exist. In the other hand, A union A naught is the universal statement because A naught includes every element in universal statement that is not A, while A includes itself A. So A union A naught is the universal statement. And the number of elements in A and the number of elements in A naught is also same as number of elements in the universal statement. I think this concept is pretty okay. Then we'll be moving on to an example questions to show you how to solve these type of questions. Let's try to cover the answers for right now. We're looking here. All right. If there's a set of numbers called U, consisting, actually I can't cover the answers anymore. You know what? Just ignore the part I said on the cover answer. If there's a set called U, which U with the elements -3, -2, -1, 0, 1, 2, and 3, and there's a set A of -2, 0, 2, 3, and set B of -3, -2, 1, 3, we'll be able to answer the questions listed here. So they first want us to list A naught. So all right. First of all, A naught is all the elements that are not within A. So I'm going to that are in the universal statement. So I'm going to erase each of this sets together to easily notate. And now all the numbers left over would be A naught. So A naught would be -3, -1, 1. That is pretty straightforward. And just gotta refresh these numbers. And we're going to look for B naught. In this case, we're going to erase all the numbers within. This looks like a 3, so annoying. Okay. So I'm going to erase all the numbers within B in the universal statement, and the leftover number is going to be B naught. So -3, -2, 1, and 3. So we only have -1, 0, and 2 in B naught. B naught equals -2, -2. Oh, and that goes -1, 0, 2. Yeah. All right. So next question is going to be A intersection B. So A and intersection B is going to be the same values that A and B share. So in this case, it's going to be -2 and 3. So A intersection B, A and B would be minus 2 and 3. There we go. And then we have AUB, which is A union B. And A union B, as I introduced earlier, is all sets of numbers together within A or B. So first, I am going to write all the numbers of set A first, which is going to be minus 2, 0, 2, and 3. Now I'm going to write all the numbers within set B. So minus 3, 1, and 3 is already in there, so I don't have to add another 3 or minus 2. You don't have to write the same set of numbers multiple times when we're talking about sets of numbers. So this would be A union B. Okay, then this is a special question. A intersection B naught. Intersection not B. All right, so all elements that are not B that we got from the previous answer, we can use this here. So it's the numbers that intersect between union A and B naught. So it's gonna be 0 and 2. So A intersection B naught is gonna be 0 and 2. And then for A naught and B naught, we can see. So next, the question was to get the union of A naught and B naught. Because we already have the A naught and the V naught set values from the previous question, we just have to get the union value of this. As I did before, I am going to attempt to write the values of A naught first, which are minus 3, minus 1, and 1. And then now I'm going to add the B naught values, which is minus 1 is already there, 0, and 2. So these values are going to be A naught union B naught. Now, finally, we have the question of n. What is the number of elements for A naught and B naught union? So in this case, we just have to count, which is 1, 2, 3, 4, 5. So that's going to be 5 elements. There we go. And one thing to advise is that this is going to be very easier when you understand this Venn diagram. However, this Venn diagram is going to be explained later in this video. Just stand tight and we will explain everything to you. Don't worry. It may be a little confusing because of the wordings that they use, but probability and statistics, in my opinion, is more about how you gain your experience, and the experience is equivalent to knowledge. So if you just practice again and again, you'll eventually get better and better. So don't worry. All right, then let's move on. Now we'll be looking into sample space. Sample space, as definition given by the textbook, is the set of possible outcomes of an experiment. Experiment in this case is the set of numbers or the probability we have. I'll be looking more into that as I explain about Venn diagrams and 2D grid tree diagrams, and so on. Okay, ways to visualize sample space and probability. Now, the first way to do it is list, and this is pretty much the most easy, not most, this is the most common way of doing a probability question, which is listing out the all possible outcomes. So, for instance, as the question gives, when two coins are tossed, the possible outcomes are two heads, heads and tail, tail and head, and two tails. Now, so the probability representing it would, if you list it out, would be in this format. So head, 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 tail, tail, head, and tail, tail. And obviously, this method will not work for probability of counting like bazillion coins, but it's a really easy way to solve simple probability questions. Now, another way to solve probability question is using the tree diagram, and this is a favorite in a lot of different math questions, especially probability questions. It's useful for listing a sequence of events. So if you look at the example my friend gave, choosing a short pants and a sock. So, shirt, pants, and sock. Oh my God. Okay, first there's the 1/2 chance of choosing a green shirt or a blue shirt. And then out of the green, after you choose the green shirt, you can think about the chances of um, getting a gray pants or a black pants. And then inside that choice, you also have three more choices of three different color socks. So as it's written here, the probability of choosing a blue shirt, gray pants, and green socks would be 1/2 here, 1/2 here, and 1/3 here. So multiplying that all together, since they're independent events, it will give us a 1/12th chance. Another way I can make a question here is, what is the probability of choosing green shirt but not black pants? Because we want to choose the probability of green shirt, first we look into the 1/2 chance here. So I'll be highlighting this way. So we go this way. And then here we don't want to choose the black pants, so we don't want this guy. Then we go over to this road. However, because the question states that doesn't just talk anything about stocks, we assume that any type of color of stocks is fine. So all of this is one probability. So if you write that down, it would become 1/2 from choosing green shirt over blue shirt, and then multiplying 1/2 again. It's because we want to choose gray pants over instead of black pants, and then you multiply 1 because this whole choice adds up to 1. That would give you 4/1 chance, so it would be 25%. This tree diagram can come a little difficult if they start asking you about assuming something happens, but I'll be dealing with that a little later. So let's move on to Venn diagrams. Venn diagrams is an alternative way to visualize combination, two sets or subsets. And I kind of implied Venn diagrams important up in the unit here. This guy while explaining complement sets. And um, Venn diagram is first you have to, before you learn the specific things about Venn diagram here, the definition of Venn diagram is that Venn diagram consists of universal set U represented by a rectangle and set within is that are generally represented by circles. This is not like a universal law that everybody does have a square universal set and then you have circles in the middle. You can have squares in the middle like this, but it looks ugly, so they choose to use circles. So before we move on to learning what a Venn diagram, how to use Venn diagram, first you have to know the different terms union and disjoint of mutual exclusive terms. And if you noticed, we kind of learned this words over here. No, not here. Here we have union, and then we have mutually exclusive here. So these terms should be familiar, and if it's not, I recommend you go back and check on the names. But just to briefly go over, AUB consists of all elements in A or B or both. It is a shaded region which includes everywhere in either circle. Disjoint or mutually exclusive have no common elements, and they're represented by non-overlapping circles. Before we look the writing in red, let's look over the writing on red here first. A combination of these four main areas can be used for any combination of two sets. This may be a little confusing, but this will become more easier to understand as we solve the questions, so just you wait. And for all of these combination, try not to memorize them. Rather, identify the set circles, how the operation u, n, and slash not, and remember bracketed terms to go together. A and B means not A and B. Yep, these things are straightforward, and I explained them before, so I'm just gonna move on to explaining intersections. So intersection is, again, I said it before, it's A and B. It consists of all elements common to both A and B, and I said it's A because it's A and B. They have to have an overlapping value, and using the Venn diagram, we can understand that that value is right here, the overlapping side. And yeah, let's just try looking into that. It is that shaded area where the circle representing A and B overlap. Yes, A is shaded, A and B is shaded, B not, since everything besides B has to be applied. B not is shaded, and A and B not is shaded. I think these are straightforward. On separate Venn diagram, shade these region for two overlapping sets of A and AUB, A not and B. A and B not. Yes, you guys can try this by yourself. I don't think this is a major issue that's going to come out in your tests, but let's see at this question, because this question is a little fun. Yeah, okay, I'm just going to try to cover the answer. Given NU equals 40, and A equals 24, and B equals 27, and N, A, and B equals 13, find NAUB, NA, and B not. All right. First, since this notation gives us the universal set, we know that the total number of set we have is 40. This guy will be n. And NA here inside a circle, we have 24. The whole thing is 24. And then NB is 27. However, it says that A and B, so NA and NB equals 13, which means that they have a overlapping side in the middle. So here and here we have A and B, and in the middle, as it says, we have 13. So what we know is that since A total has 24, this would be 11, since the whole circle has to add up to be 24. And we also know that since B also have to add up to become 27, we know that 27 minus 13 is 14, so this part of the number would be 14. So now using this, if we want to get NAUB, that would give us, since U represents OR, we just have to add all the numbers here. So it'd be 11 plus 13 plus 14, which gives us 38. And N, A, and B not would give us, so N means and B not means we have to do every side besides the, I'll use this color, besides B. So every part here that overlap with A, which means that it's gonna be the area here. So it'd be exactly 11. Oh, wait, let me just erase all the highlights. And then we have the final, oh wait, no, that was the final question. Yes, so this is the way you can get it. And If my explanation is not is a little confusing, you can look at the solutions. And let's look at the tip written here. Don't get confused between the value of n and the actual value with these sets. Oh, so what this means that if they give you this number set like 4, 1, 2, 3, 4, 5, this doesn't mean that like you have one number in one set, two number in two sets. It just means that n has like inside n there is 1, 2, 3, 4, and 5. So yeah, don't. He just means that don't get confused with having like five numbers in n. Um, yeah, so something like this. And another red note here for MYP, any Venn diagram, 4 up to 3 circles will come out. 저 4 맞지? Okay. 4 up to 3 circles will come out. Write down all the information given, organized into the Venn diagram, and you should be fine. Yes, if actually Venn diagram, in my opinion, is one of the most difficult things that can come out if it comes out into three sets of circle. So make sure you guys practice this Venn diagram thoroughly, and we will be providing some example questions, especially regarding this three-circle Venn diagram. So check that out and then study tightly. And 2D grid, honestly, in my opinion, this is very, very opinionated, but I don't think 2D grid is really needed in solving probability because 2D grid can be like done with every other things we have learned. But because since MYP includes this part of the curriculum and maybe the question will ask you to draw a 2D grid, I recommend you study and know what this concept is. So 2D grid is basically representing one event on the x-axis and another event on the y-axis. So this is very restricted to having two independent events. If it goes over two, you have to write 3 dimension, and that's gonna nauseate you like crazy. So each dot represents a different outcome, but can only be used for two events at once. Yeah, as I said. So for instance, rolling 2 dice or rolling 2 coins. What's another probability thing that could happen? Drawing a ball like from two different boxes. So the maximum amount of events we can have is 2 events. So I'll just give you an example of, let's say, rolling 2 6-faced dice. So in x-axis, I'm gonna do dice 1, and then the y-axis, I'm gonna do dice 2. And obviously, because the six-faced dice, the only outcome that we can have is 1, 2, 3, 4, 5, and 6. Actually, let's draw this in a straight line. Give me a second. Yep. So 1, 2, 3, 4, 5, 6, and then you can draw another 6th layer, since the second dice would only have 6 chances too, since it's a six-faced dice. As you can see, this steps takes a lot of time, and if you, I would just recommend rather using the listing method if you guys are gonna try to use the grid method. So, for instance, if you want to get like outcome of probability, not probability, let's do chance. chance of drawing at least 1 3 from the 2 dice. So like we want at least 1 dice rolling a 3 out of the 2 dice. They can overlap. So what we'll do is, looking at the grid diagram, we will look into here as we'll look into here because we want to get so we look into the 2D grid and we look into number 3 and we see 1, 2, 3, 4, 5, 6 outcomes. And looking, because we have another dice, we look into the 3 in here, and that would give us 1, 2, 3, 4, 5, 6. But since there's 1 overlapping, if we count the number of outcomes, that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the chance would be 11. So this is a way you would use 2D grid, but as I stated again, just know what this is because the test might ask you to draw a 2D grid, but normally if you're just calculating probability, use the listing method instead of the 2D grid method. 계속 갑니다. 중간에 잠깐 뜰 건데 이건 내가 뭐 빠르게 지우지 뭐. Okay, next we have range interquartile range and standard deviation. Fun fact, this guy is going to come out in DP2 and it's going to drive you nuts if you're going to do AAHO. Yes, anywho, that's a future statement. And knowing the middle point of the data set can be quite useful, but for a more complete picture of the data set, we also need to know its spread or variation. So 3 commonly used statistics that indicate the spread of the data sets are range, interquartile range, and standard deviation. First of all, let's start with range. The range is the difference between maximum data value and minimum data value. That is pretty straightforward. Later, if you go on to functions, there's another definition of range. But until then, in a normal set of numbers, the range is highest value minus the lowest value. So in this case, my friend made a mistake, but since the highest value, let me just erase that. Since the highest value is 9 and the lowest value is 2, the range is 7. Yes. Maybe he was a little sleepy making this document. Don't be so harsh on it. And then we have the interquartile range. The median divides an order. And then we have the interquartile range, where the median divides an order set in halves. By finding the median of each half, we divide the original data into quartiles. So, as my friend read in red, must be ordered just like for the median. Yes. The interquartile range is the range of the median half 50% of the data. So interquartile range is upper quartile minus the lower quartile, and I'll be explaining this through an example question, but you can also check out this page in the Haese textbook if it confuses you a lot. Let's see. For the data set, yada yada yada, wow, that is a lot of set of numbers. Find the median, lower and upper quartile range, interquartile range. So first, what did I say when we want to find the median? The first step is always to list the numbers in increasing order. So I see 3, which is the lowest number. So 3, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6, 6, 7, 7, 7, 8, and 8, and 9. Let's and always make sure to check if the number of sets and your increasing order set have the same number. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And I should also have 19 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, 17, 18. As you can see, I have made a mistake in the number of sets, so I have to look back and see what's the mistake. I actually know the mistake because I actually intentionally made the mistake so that I can tell you how to check if you're missing a number or not. I missed a 6, so I'm gonna add back a 6. And yeah, next, what did I say we do? So what you do for the interquartile range is that you find the median, but you do it with the lower half of the data besides the, compared to the median, and then you use it with the upper hand side of the median. So we agreed that the median is 6. Since we know that median is 6, we're going to eliminate that 6 in the middle. So I'll eliminate this guy because we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the other side we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So we're going to eliminate this 6. 다시 한번 할게. Now what we're going to do is we found that this number is the median. What we're going to do is we're going to eliminate this number. We're going to move it outside of the set. And now what we have is we have 2 sets of value without the median. Now, to find the lower quartile range, we're going to find another median value from this newly created individual set. And then to find the upper quartile, we're going to find the median from this set. So let's see. Using the elimination method, 1, 2, 3, 4, 5, 6, 7, 8. So we have 5 here. And then let's see. 1, 2, 3, 4, 5, 6, 7, 8. We have 7 here. So the lower quartile is 5, and the upper quartile is 7. Let's see. So now that we have the lower and the upper quartile, if you want to find the interquartile range, as the equation as the formula states here, it's the upper quartile minus the lower quartile. So this is not a, by the way, I just noticed how confusing this line can be. I'm just going to erase this line because you might think that it's a division line. No, it's not. I drew that line, so don't worry. The book is never wrong. I mean, it sometimes is, but Haese book tends not to be wrong. If we use the formula to get the interquartile range by minusing the lower quartile from the upper quartile, we get 7 minus 5, which is 2. So the interquartile range is 2. Okay? So understand the definition of these different type of methods, and then you'll be okay. But we're not done because we have standard deviation, the most annoying one. And even my friend wrote, this usually doesn't comes out, but it did once. So maybe we should learn it. Honestly, this standard deviation is, as I said, pretty out of reach. Like, you don't need to specifically know and understand fully about this topic, and then you don't have to be a master because you learn it in DP anyways. But as my friend said, it has came out in the eAssessment once. So if that really worries you, and if you don't have other things to study, I know how eAssessments can be tough, and then you have other subjects to study besides math. So I won't be going over this topic, but if you're really okay and you really want to get a good score in math, I also recommend studying this part too by yourself. And the book pages are here. So if there's anything confusing, just email me. We'll put the email on the our YouTube descriptions. And you can also ask your teacher anytime. I know they're all experts about it. So you just know that this topic exists. And then if it really worries you, ask your teachers and try to learn it by yourself. Because it is pretty difficult since it comes out in DP and you already see sigma notations that you don't need to learn. And then you have the different deviation numbers, and then you look at these difficult calculations. So let's move on. But correlation is something that comes out, and it has came out every year. Not every year, that's an exaggeration. Correlation also oftenly comes out, so you have to learn this guy. Correlation is the measure of strength of the relationship or association between two variables. So the most, not most. So the thing you have to know is look at the spread points of to make a judgment about the strength of the correlation. So linear relationship between the variables, and non and let's see. As you can see, we have for the values we have strong correlations. There's okay. As you can see, since a lot of the data points are very near to the linear correlation here, we say we have a strong correlation. And this guy seems moderate because it's scattered out a little. And this is weak because there is no pattern. Now, some people like question like to what extent is moderate and strong? Like how do we define the two difference? Well, the short answer is you can't. Like it's your standard. If you feel like oh there's a really good correlation, you just say strong. Maybe for you this type of things also shows a good strong correlations. Maybe the data set is like 0.01 centimeter, and that's not a big difference. So actually this shows a pretty good correlation. Maybe that's the case. The judgment is yours. I don't think the IOB will ever demark you for calling these two type of graphs one strong and one moderate, but you cannot call a weak correlation graph a strong correlation. That's for sure. And I also recommend don't. I actually just don't recommend using the word moderate because it's such a broad term. So I rather just stick with strong or weak and then justify the reason and then you'll be fine. And one tip my friend wrote is that strong correlation doesn't necessarily mean the values are increasing or there's a positive or negative correlation. It just means there are a strong relationship with the database and the correlation graph. And yes, not some the graph doesn't necessarily have to be always linear. There can be non-linear graphs like this guy. And let's see. You are not required to calculate the numerical value for the strength of the correlation. Yes, don't. Look at this psychotic equation. Do you want to calculate this? No, even a DP student like me, I don't want to use that ever in my life. So, yes, just see the definition. I recommend you don't really need to see this part. Just read this part out and then you're okay. Just understand there's a strong positive correlation and strong negative correlation. So in this case, this is a strong positive correlation because the data are aligned together and it's a positive graph. While this guy is a strong negative graph because it's pointing down and then there are strong correlation. So something like that. Finally, we have line of best fit. Oh yes, I love this part. Yes, for the line of best fit, you're never required to calculate. You only are required to sketch by eye. So what this means that is very relative, and unless you don't draw a super weird graph, you would be okay. So there are pretty uh mathematically advanced written steps, but the real thing about line of best fit is just see a good looking graph that's going to fit every data point. So for instance, if I just give a small example, oh my god, what is that? Maybe the data is like this. Obviously I don't know the specific best fit data that is mathematically proven, but because in your level you just have to use the eyes, any graph that looks like this would be okay. So how the IB does it is like they set a boundary, like if the graph is pointing towards inside of these range, you get the point. So you don't have to like forcefully think, oh my gosh, this is the best fit equation and best fit um graph, and I have to draw it very very closely, touching every point and freak out something like that. Just make it look good and make it look persuasive, and it's fine. Okay, let's see. Yes, you won't be asked to calculate the exact line of best fit using linear regression method. Linear regression method is the ugly looking equation like this guy right here. And then good to know how to do it on your calculator though. Yes, that's a tip, but not for your test. Not yet. So this is an example of how you would draw a um, line of best fit. And one thing I also wanted to recommend. Oh, even though my friend did say we don't have to find the exact line, in my year we were asked to draw a line of best fit and then find the slope of it. So this also has a range of answers, and if you're fit in that range, you're okay. So you don't have to freak out and then suddenly start thinking about how should I get the uh gradient of the slope of the graph. You just have to simply look at the graph you drew and then find the slope from there. And then maybe you can modify your graph a little so that it's easier to get the slope. And that would make your life a little more easier to test. Since sometimes for some people, you don't have enough time for your test. So this is the end of statistics and probability. One thing to make sure is that this part of the unit has a lot of definitions and different terms, so you have to all understand. And I gave a lot of many tips throughout the whole questions. And just understand that we're trying our best to give the best type of tips so that you can go through the e-assessment. So I recommend you look through the video one more time and then take notes thoroughly. And for the probability part, I really recommend practicing again and again till you understand, you get a sense of how to solve these type of questions, because these questions can be very confusing when you meet in the test. All right, so that's the tip, and I hope you guys do great on your test. Thank you.